it's done even better than that as well. So it's bumped up by, about 8% or something overall. So I think this week there may not be many learning points for people because a lot of answers have been input correctly in the first place. But let's go through them nonetheless. Of course, a lot of this content is related to the laboratories. So it did require you to go through and read the laboratories, and it's good to see those questions done very well. And then, of course, at least half of it is related to the theory on black box testing. Can't cover all of it, but remember, stuff that isn't assessed in your IRAT, TRAT quizzes, etc., is likely to maybe come up in the examination. So things that have not been assessed so thoroughly previously will have a higher chance possibly of coming up in the exam. And I'm saying this as someone who has not yet set the exam, so I'm not trying to give you any hints. Well, I guess I am giving you hints, but I haven't set the exam yet, so I'm not telling you what's in it because I don't know what's in it yet. All right, without further ado though, let's look at question number 1. Of course, this might be everyone's question number 1 because I managed to create a partition for, mistakenly, but I'm not sure if that definitely made this question number 1 or just created a random partition. Interesting. Either way, this one was done extremely well, as was the next version of this. So in use case testing, it's a form of black box testing, of course, and this is something you're quite familiar with in terms of identifying use cases. Now, when we want to map these to tests, of course, we need to know quite a few things. We need to know the preconditions, the post conditions. We need to know the primary flows, the alternative flows, because we want test cases for those. But we want to know the actors involved, etc. So actually, in this case, we actually want to know all this information, and this is what's specified in the notes as well. So 97% of you getting this correct. Well, this is really just from the notes, but also if you have to derive a test case, of course, you'll need to know all these things like the context, the preconditions, everything to be able to arrive at a set of test cases for your use cases. So this one very well done. Also, the alternative version of this was not so well done, but it was yeah, I gave some things that use cases should be, and they were up to date, readable, etc. And I guess some things they shouldn't be. And most people were getting the correct answer there, but some did think that all of the options were wrong. However, some of them were directly quotable from the slides, talking about them to be readable and up to date. So this question overall, I think done pretty well. This version was done exceptionally well. Now let's look at some equivalence partitioning. So this is not, of course, boundary value analysis. This is just the equivalence partitioning, where we're trying to identify different partitions to test and trying to essentially classify our tests into these partitions to make the testing more efficient, right? So we don't want to have a lot of test cases which effectively test the same partition, the same expected result. It's kind of redundant and can be, by definition, a waste of time. Now, in this case, we're applying it to this unsorted array of integers, and this is specified in the notes from the International Testing Standards. So we have our array here, and we have them linked, element 1 to element 5. We've got our various numbers in the array. We've also got a restriction as to what can be inside the array. So positive integers greater than 51 and less than 61. Of course, you've got to be careful about the greater than and less than, whether they're inclusive or not. Of course, this doesn't specify they're inclusive. And, hence why we have test case at boundary limits, because it's easy to misinterpret these things. In general, though, the vast majority getting this correct. So if you go through each of these in the notes, what are we looking for? So we're looking for a test case where it's valid and in the array. Okay, so 52 would comfortably meet that. We're also looking for a test case which is invalid, so it doesn't meet the parameters. And in this case, 51 is invalid, right? Because its integer is greater than 51, so it meets that. And then we're finally looking for an input which is valid, but it is not within the array. And of course, 58 would be valid, but it's not in the array. So option 1 looks good, but actually all the options look good because 56 valid, not in the array, 57 valid in the array, 60, 60 valid in the array, 57 valid in the array. Oh, sorry, this is a different version of the question. Just the first one is looking good. in the in the IRAT version, actually all the answers were correct, and this is the version where the TRAT version where not all the answers are correct. Yeah, I think I started going through them and like, wait a minute, 57 and 60. So 57 and 60 are obviously repeated test cases, and you're not actually testing invalid case here, which is why that's missing. And in the third one, you're testing two invalid cases, which is 51 and 10, and then not testing something that's valid but not in the array. So the other two are incorrect. In the IRAT, all of the options were correct, given the same reasoning that I kind of just went through there. And so this is the TRAT version, and the majority are getting this correct. So just again, this is the equivalence partitioning from the notes. We're looking for something valid and in the array, something valid and not in the array, and something invalid. Okay, that doesn't meet the precondition. So, oh yeah, okay, added it here as well. So precondition true is in array, inputs precondition is false, 51. Inputs precondition is true and isn't in the array, 58. So 58 is true but not in the array. 51 is actually a violation of the precondition because it's greater than 51. Okay, so I won't keep repeating myself here, but generally this one is well done. One of them had all valid test cases, and this one in the TRAT did not. Okay, so now we do go into some of the boundary value analysis, or BVA. And so this is, as mentioned, used alongside equivalence partitioning. But as I mentioned kind of in the break, do be careful when you're reading up on this. This is, an extension of or further, or different from, I should just say, just basic equivalence partitioning. And if you're looking at websites like Guru 99, which is a great website, you need to be specific about the areas you're looking at. And someone, made the mistake of not doing that last year. Anyway, in boundary value analysis, there are the kind of more traditional, old school way where you would test the boundaries and the values inside the boundary value and outside the boundary value. And then there is the more modern way where you would just test on the boundary because that's already inclusive, and outside of the boundary as well. And so if you're choosing the minimum of those, it would be the one with the least test cases. Now, I'm not sure if this is the TRAT or the IRAT one. I don't want to make the same mistake I just did a second ago. Looks like it might be the TRAT one. Yeah. Oh, yeah. TRAT one. Yes. TRAT one. Yeah. It looks like the TRAT one. So in this case, actually, none of these options are looking particularly good because we're not testing. The first one is testing the boundaries, but it's also testing inside one of them, outside the other one, etc., etc. So all of them have their own issues. And so actually none of these are the correct options because you're not testing specifically on the boundaries and just outside the boundaries, which is specified. And 90% of people getting this correct, 90% exactly. So it's good to see that. And regarding the IRAT version, there was a valid BVA example given, 10, 101, and 100 when the range was different. And again, most people getting that one correct as well. So it's just basically applying the technique from the notes regarding BVA for this input range. You go on to the boundaries, the valid boundaries, and then just outside the boundaries as well. So yes, this is the one from the IRAT version as well. So inclusive of both boundaries. Okay. So anyway, it seems like these questions have been done very, very well so far. So if you have any questions, of course, you can fire them in the chat. You can drop me emails. But so far, so good. And overall, the results obviously very, very strong. So let's just see. Now, this is where the questions start getting a little bit jumbled for me because I did add, different questions, more substantially different than I have done in previous weeks, just to try and mix things up a bit and be able to ask, some questions that I otherwise might miss. But this one is relating to decision table testing. And so, just going from memory here, is basically I give you a paragraph description of how the system should work. If you're given like a user ID that's false, then you go to the kind of imposter page. If you're given the user ID which is valid and a valid resource code, then you book the resource, or a valid user ID and false or fake resource code, you would go into the resource code list. So you're hopefully helping you get a valid one. And there's also a specification as to what the inputs are in terms of, 3 integers or 3 characters, etc. So given the test cases here, at the bottom, and then the main thing is you're looking for the logic from the rules for the decision table testing. So what you have to do is obviously discern, the correct mapping from the paragraph description. Now, is this the TRAT one? I did have a version of this in the IRAT as well, but anyway, this is the TRAT version where none of these options are actually correct, and it seems, yeah, oh, 90% again, exactly 90% again, getting this one correct. And if I just go to the IRAT, has a similar version, but they have a question where one of them is actually correct. So the mappings are actually correct for the logic in the rule 1, 2, and 3. But again, about 70% getting that right in the IRAT, and then the TRAT, 90% getting this one correct as well. So this one is just more about kind of careful reading and mapping the logic from the paragraph into the logical structure of the decision tables. And that obviously requires a little bit of understanding of the decision tables themselves. Not that they're overly complicated, but it seems that most people have quite adequately defeated the decision table questions. So let's go on to state transition testing. Now, this sometimes trips people up, but actually, if I can find the question. Where is this question? Is this the IRAT? Well, my questions are all in fantastically different orders, but most people are getting this correct. This is to do with zero switch and one switch tests. And so this is when we're representing things as state transition systems, and you might come into more of this later on. So it's essentially a system can have a current state, which means that, say, the system has variables X, Y, and Z, and these are the only variables in the system. A slightly contrived example, right? But a particular state will have a particular evaluation of those variables. Maybe X is 1, Y is 1, and Z is 3. And this will be a unique state in the system. And then you can have, some sort of event that occurs which changes Y to 2, and that would effectively create a transition to a different state where you have 1, 2, 3 as the variables, or whatever I said previously. So this is state transition diagrams are a much more rigorous and formal way, and more traditional in some sense, way of representing systems. So they each have these kind of unique internal states. And when we're testing, we're trying to, for zero switch, actually create tests which just test for each of the transitions. So we are testing that we can transition from state 1 to state 2 correctly, as specified in the diagram here. Now for one switch, we're actually testing for all those combinations of unique transitions. So you'd be looking for S1 transitioning to itself, then transitioning to S3, for example. But we're not doing, double loop. So you wouldn't do S1 to S1 as a double for a one switch test, and it's specified in the notes. Oh, thank you. Thank you. Someone's keeping me right with all the information on the TRATs or IRATs. Anyway, for this one here, yes, so this will be the TRAT then, I guess. So we're looking for 6 tests for zero switch, which you should hopefully observe from the number of transitions, and that should give you a limited array of answers to choose from. So you either look at A and B and ignore C and D. And then we have to decide whether it's 10 or 11 tests. So we can actually map these out, of course. So there's S1, so from S1, you go to S1, then you go to S2. So that means we take the loop transition, and then we take the transition to S2, S1 to S1 to S3, S1 to S2 to S3, S1 to S3 to S1. And you can keep applying this process from S2. There's only 2 we can go through, here to here, then here to itself. And then from S3, we've got S3 to S3 to S1, S3 to S3 to S1 to S2, S3 to S1 to S1, S3 to S1 to S3 as the last one there. So anyway, you can follow along here, but essentially we're looking for 11, and 81% of people getting this correct. So this one is, of course, another example of understanding, but also with some careful reading. It's easy to miscalculate these, but I did try and kind of narrow down people's options. If you understand zero switch, then it should be more just counting between the 10 and 11 tests. So I did have a different version of this in the IRAT, and oh yeah, I was actually saying 81% of the IRAT got this correct, and actually in the TRAT, 89% got it correct. So people were learning in between, which is great to see. For the IRAT, it was a 5 switch. For 0 switch, sorry, 0 switch of 5 tests, and a 1 switch had 8 tests. We were really just missing one of the transitions here from the top and one of the loops, and then instead of 1 transition along the bottom here, there was 2 loops going backwards. Anyway, the principle is exactly the same, and this type of thing will be more prevalent in the second half of the course, where a lot of formal methods do involve representing systems as state machines or state and transition systems. So I think this one largely very well done. So let's move on. And again, I'll be, dashing between different IRAT and TRAT questions. Just trying to work out where I am. Oh, I had a similar question to this for each time, apparently. So anyway, we're talking about automated testing. It's covered in Lab 3. Specifically, some myths about automated software testing are mentioned. So generally, with a lot of the material I teach, I'll try and give the kind of pros and the cons. I think it's important that, although we're learning about testing, some of the principles and practices and a lot of the standards specified by the Independent Testing Qualification Agency, it doesn't mean that all of it is necessarily perfect or useful. And in terms of automated testing, something I've mentioned to a lot of people in the labs, actually maintaining a set of tests can also be onerous as well, in terms of all the adjustments of tests over time that you might have to do. So you have to maintain your tests as well as your code, etc. And obviously there's a huge upfront cost when you're trying to create some automated testing as well. So there's not always like a perfect ideal solution, but there are better and worse solutions given certain situations. So we talk about some myths of software testing, and then there's some kind of statements in the laboratory where, in the laboratory text where I'm kind of dispelling these myths with some quotes from the software testing book, which is an excellent book. So which of the following are correct evaluations of those statements? So all the statements they're saying is, automated testing is not necessarily faster than manual testing. Automated testing, well, okay, now I know which version of question this is. So just keep reading them out. So automated testing always leads to more defects being created. Well, I mean, always leads to, sounds a bit dubious to me. Automated testing has a low, I mean, it might lead to, but automated testing has a lower initial cost to manual testing, but it will cost more to maintain. Well, it will likely cost more to maintain, but it will also not have a lower initial cost because setting up a set of automated tests is obviously more troublesome than actually just conducting a manual test there and then. So really the answer we're looking for here is, of course, the first one, where automated testing is not necessarily faster than manual testing because there is that upfront setup procedure, etc. So it depends on the number of tests you want to do and how frequently you want to do them, whether it's more efficient. But in general, it could be for bigger systems over time. So this is the TRAT version. No, sorry, this is the IRAT version. The TRAT version, actually, all of the options were correct. And in this one, 92% of people got this correct. But in the TRAT version, actually, I had all the statements from the laboratory there. Automated testing is not necessarily faster. Automated testing does not necessarily fix. Automated testing does not necessarily fix more bugs than manual testing, etc. So it was just basically all taken from, slightly paraphrased, but not really from the laboratory sheet. But anyway, automated testing is obviously very powerful. It's kind of what we're doing here. We're setting up automated tests for laboratory 3. Doesn't mean it's the best practice, no matter what. There are certainly some pros and cons, and certainly some considerations needed as well. Okay, don't know what happened there, but we'll move on to question 7, whatever that might be in my. So this is to do with our dependencies. I'm not sure there's any point in me looking where this is. This is somewhere in one of them, maybe both of them. Okay, so in lab 4, we created an external dependency in our calculator program. I mean, this was a bit of a contrived one, but of course, we created this external dependency to this file reader that we generated. And so what is the significance, if any, of having an external dependency when performing unit testing? So this gets us into the kind of nuts and bolts of unit testing. The idea is to isolate our functions for our tests. We want our test to test our function only, only testing that one unit, that kind of hypothetical unit that we talk about in unit testing. And so if we have other functions, other people's functions, other libraries, etc., we don't want to implicitly test those whilst we're testing our functions logic, let's say. And so that's what we did in lab 4, where we learned about how to actually circumvent that using kind of the well-trodden path of using mocks, mock objects and things like that. Now, of course, this adds another layer of burden to developing test cases and such, and another layer of knowledge which might be kind of antithetical to being efficient with your workload if it's not necessary. But for strict unit testing and correct unit testing, we do want to remove our dependencies from those tests, and that's why we would use mocks and possibly in that situation. Okay, so choose the correct statements from the following. So to correctly perform unit testing, there is a need to remove dependencies such that they are not implicitly tested too. Sounds exactly kind of what I was saying. That is, we ensure that only one thing, a unit, is tested per test. And then the other options don't sound so useful. So there is no significance in inclusion of dependencies as a unit test is still being performed correctly without dealing or removing them. Well, that's not true. That is not correct unit testing once you have dependencies in there. And to correctly perform unit testing, the dependencies of a function must be tested within the same unit test of the function with additional assert statements. Well, this is violating a whole ton of principles. The idea of having multiple assert statements is also bad practice in testing in general. Anyway, brings us back to the correct answer, which is A. I can't seem to find where I put this question, but it definitely came up somewhere, right? I guess it might be in the TRAT then. Yeah, it must be in the TRAT. Oh gosh, I can't even find this. Oh, okay, yes, it was in the TRAT. I had it further back, and actually 94% of people got this correct. So I guess I don't need to continue babbling about this. I think there was another version of this which I created, but I'm not sure. I'll just double check. Yes, so there was another version I created about this in the IRAT, in which case I had a whole ton of wrong answers and none of them were correct. And yeah, 83% got that correct as well. So vast majority understanding the principles behind having dependencies in unit testing and why that might be an issue, which is great, which is the essence of the laboratory. Okay, so moving on to dependency injection itself. So we did dependency injection, of course, into our well, initially we did it via the constructors with a spec flow, but then we changed to do it in the properties, right? Sorry, not the properties, the parameters for our methods when we were dealing with lab 4. And so we had two versions of this question. I think this is obviously the first one. There are a variety of approaches to do this. What is meant by dependency injection, and what is being used in lab 4, specifically in the lab? Well, of course, none of these, right? As I just mentioned, we're using by parameters for the function. We're actually using the, you can have an overload method where you have the I file reader being passed in, which is what we did. Or you didn't need to necessarily create an overload, but you just pass in the dependency as a parameter. In our case, we could then pass in a mock or an actual file reader, depending on what we are doing, if we're running the real code or we're doing our testing as well. So none of these, we're looking for parameters. Oh, this is helpful. And this is, of course, we passed in by parameters with the ifile reader object. Obviously, this overloads the method signature, but it does allow us to inject our dependencies that way, and we can inject our mocks. If we've used an ifile reader, we can create a mock around our interface, which we did, or the laboratory. So yes, I think probably people did very well on this one. I think this was generally written up quicker than the lab. Yeah, you can see 83% getting this correct for the parameters, which make in the IRAT. So in the TRAT, I think that means everyone must have got this correct. yeah, 94% getting this correct in the TRAT where none of the options are here. So it seems like you guys are following the laboratory material very well. And if not, you're just understanding what we're doing, which is fine. So let's move on to mocks. So I did add an addendum to the laboratory sheet, which discusses mocks and stubs. I think the general use case is obviously different. Stubs and drivers are really used for integration testing. If you want to test a driver, which is like a program which maybe calls other or uses other objects, calls other programs, you would possibly use stubs, which are basic implementations of some of these lower level functions, programs, and then the driver would just call these. And that depends if you're using top-down or sandwich or whatever integration you're using. Whereas mocks are really when we're trying to remove our dependencies from our specific tests. Although you could obviously argue you could use a mock to replace a stub or whatever as well, because it really is just a replacement of the actual implementation. So anyway, it's important to understand the difference between a mock and a stub. So these are all just kind of paraphrases and different expressions based on the notes, and all of these are correct. So mocks are dynamic wrappers from dependencies and tests. Stubs use user program classes that mimic dependencies behavior. Mocks use knowledge of the sequence that dependencies should be received from the system under test. Yes, because we actually, for mocks, we really do need to have that specific knowledge of the kind of inputs and output, the order they're called, etc. So all of these are just rephrases of the laboratory material itself. And yes, 81% people getting this correct in the TRAT, which I think this is mainly a TRAT question, which brings us to the final question, which is something I harped on about to a lot of people or anyone that would listen to me in the lab. And some people were brave enough to question whether my description of this was accurate, in terms of they were suggesting that perhaps it doesn't work as I mentioned, which was great, to have these kind of dialogues, because things do change over time, and no one's infallible, but this does work in a slightly counterintuitive way, I think, initially, but once you kind of get familiar with it and play about with it, kind of hopefully get the same conclusion. So anyway, 90% of people got this correct, so not too much point dwelling on this one either. But this is just to clarify, this is our mock setup that I provided in the laboratory. And a lot of times in the labs, I was really questioning, what is this line, this setup line, where we're kind of mapping our FR, this kind of function here. So what are we actually doing in this case? And so interestingly enough, we're really just mapping this kind of input string for this function read to return this array of strings as an output, right? So we're really creating this kind of mock function. So our mock object is kind of pretending to be a file reader, right? And so it has to have some implementation of the functionality of the ifile-reader dictates, right? And in which case we need to have some version of this read function. But all it's doing is taking this string mapping as an input and providing the output. And this is so that we don't have to rely on this dependency. We just have this simple input-output mapped. And so we know that if we send in this, it should return that, and then we can just worry about testing the actual logic of our function itself. So in this case, of course, we're looking for, this line is creating a mock function that returns an array of strings when given the input text magic numbers.txt. Now, if you, of course, change this text to whatever, then you would need to change that text in your actual function, or maybe have different versions of the function, depending on, if you want to have an overload with our alpha reader input or not. But ultimately, if you don't have this text in your actual version of the function, whatever's in here, then it's not going to return the correct result because it's mapping that text to the result. Now, you could obviously use regular expressions here, or you can take a read that has no parameters, or whatever you want to do to make it more generic, so you don't necessarily need a specific text file. You could just use anything. But if you use the same file path text in here, then of course your function will work for both the real, where it uses the actual file path, or the mock, where it would use the mock return from that file path text, which is what we started with using in the first place. So I was really impressed to see, the vast majority, in fact, almost everyone I talked to had this working. I think everyone I talked to had this working. So that was excellent to see. Yeah, and I think, this week has probably gone better. It's certainly better than last week, possibly better than the week before. I'm not sure if it's as good as the first week, which I think was very easy, but it's certainly gone pretty well. Anyway, I think the results are very good this week, so I'm not imagining there'll be much need for questions. And one other thing, although I forgot last week, this week I will go through the quiz now, and I will adjust so that the answers which are all of the above, I will give the 0.33 marks if you selected one of the options, which was technically correct. But of course, we're looking for all of the above. I will give the appropriate marks there. So actually the scores will probably get even higher still, but you might need that buffer. I might have to make the exam super hard. Anyway, if you do have any questions, drop them here. I think we basically can finish early today. Yeah. Okay, I do have some questions. This is good. Okay. This is a long question. Let me read this out. Prof, I don't agree the TRAT question 6. Okay, great. Let me get back to that one. If I have it here as question 6, maybe I don't. Automation. Automation does not fix the development process, is different from automation does not necessarily fix the development process. Yes, the statements are definitely different. One is a stronger version of the other. So if something does not fix the development process, it's also true to say it doesn't necessarily fix the development process, because necessarily fix is a weaker statement, which does include, obviously, not fixing. So should be does not fix, would not fix, etc. The description says, as harsh as it sounds, testers don't create defects and developers do. Get a bit lost in here. The description says, as harsh as it sounds, testers don't create defects and developers do. Automated testing does not improve the development process, although it might highlight some of the issues. So not necessarily does not seem to be the right word. Please enlighten me. Okay, so this is the one on the yeah, so I guess this comes to the kind of logic of this statement in terms of if you remove the word necessarily, that's like an affirmative statement that is not faster. But if you say it's not necessarily faster, that's also that's like a superset, right? So if you have it's not faster, that's like a very precise statement saying it's not faster, but not necessarily faster includes it not being faster, and it's also could mean that it may be, indifferent or worse, or it could include other things. So I guess it just adds like a possibility into the statement. But does that make it wrong? Let me see. Let me bring up the labs so I can actually reference the description as well. This is the lab. Well, I got another question, which I'll get to in a second. Let me see, lab 3. Dun, 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 dun. Okay, so this is the text from the lab. Test automation, yep. And this is based on the not necessarily. Okay, so. Okay, so this is, wait, is this the right version? This is, are you saying, is this the version that you had an issue with? Can't speak. Or is it the other one? You say the one on screen is IRAT. So is this the TRAT one? Sorry. Yeah. Okay. Let me find the TRAT one, because this one is actually using the same terminology as I can see from the lab, right? So let's go to the TRAT version. Oh, I think in future I just keep all my questions the same. It's easier to follow. Okay. Automated testing, lab 3. Okay. So did you get this question correct, this IRAT version? And if you did, I mean, you can just drop a message in the chat. This is direct messages. So if you think I'm going crazy, then possibly also, but I'm just responding to people in the chat. So in this IRAT version, automated testing is not necessarily faster than the manual testing. So correct for IRAT. So then does that mean that you agree that that statement is, valid, right? So this is basically just a direct quote almost from the lab sheet, right? So of course this one is fine. Now in the TRAT, geez, I'm gonna have to have a lot of windows open. So in the TRAT version, I obviously tried to create different threads. Now, what did I do? So this one, I tried to indicate that they were all correct. And so, yeah, so bear with me. I'm trying to piece things together. So you're saying automation does not fix the development process is different from automation does not necessarily fix. And so the statement in the laboratory notes and from the textbook, of course, is automation does not fix the development process, as harsh as it sounds, testers, etc. Automated testing does not improve the development process, although it might highlight some of the issues. And the statement I used was, all of them are the same, apart from automated testing does not necessarily fix the development process. So you're saying that those two statements are, incompatible, right? So automated testing, yeah. I mean, I guess logically they would be compatible in the sense that saying, as I mentioned earlier, saying something doesn't necessarily fix it is inclusive of saying that it doesn't fix it. It's just one of the possibilities under the kind of necessarily. But what you're saying is that it's effectively wrong. That statement is wrong. So you're saying that automated testing does not necessarily fix the development process is an incorrect statement, would have to be what you're saying in order to change the result of the question. But if it is true that it doesn't fix it, then it's also true that it doesn't necessarily fix it, right? Unless, yeah, I don't know. Yeah, I mean, I think I see where you're coming from. Doesn't necessarily fix it. Because that statement in itself doesn't mean that it does fix it either, though. So it's not asserting that it doesn't, it's saying it does not necessarily fix the development process. Yeah, I mean, I'm not sure if I meant to include the necessarily or I just included it because it might have been on my mind from the other ones as well. I thought so, a bit confused. Yeah. I think I possibly didn't mean to include the word necessarily because it's used in all the other ones, right? No, not all the other ones, but it's used in the other ones, is it? Yeah. But does that actually make it wrong though? That's what I'm not sure if it does make it wrong though. Because it's still true. Like if it doesn't fix the development process, it's still true to say it doesn't necessarily fix it. It's a weaker statement though. Yeah, let me have a think about that one. Maybe you can drop me an email about why that statement is now wrong. Because I think I kind of see where you're going with this, because it's definitely not as strong a statement. But I'm not sure if that makes it wrong though. Interesting. That's a good question. And it's highlighted like something I didn't intend to do, which is interesting as well. Yeah, drop me an email to say why that would make it wrong. And if yes, and I will put it out on the LMS if I'm in agreement with it. I think it's possibly a reasonable case where it might make it wrong, but I'm also not entirely convinced because it would still be true in the sense that it not fixing it is still inclusive under it doesn't necessarily fix it. Okay, but I want to move on to the other ones, but as I said, please do follow up. So hi, Prof, is it possible to give an explanation for the equivalence partitioning IRAT TRAT question? Yes, it is. Let's go back to that one. Okay, this is boundary value analysis, and this is the equivalence partitioning. All right. Okay, so the equivalence partitioning one, this is, again, something that is kind of general principle behind testing, where we're trying to create almost a minimum number of tests, but that are effectively testing our code. And so equivalence partitioning is trying to look at the input partitions and the output partitions and ensure we don't have multiple tests which would test the same partition, let's say. Now, this particular question is referring to a specific construct, which would be an unordered array of integers, an unsorted array of integers. And so this is specified in the notes here, requiring 3 test cases under equivalence partitioning. So when we're testing the kind of structure, just like when we're testing the kind of the boundaries for our inputs for partitions, we're testing, sorry, not just like, oppositely or differently from when we're testing our actual inputs to a function, maybe a range of numbers. In that cases, we're looking at partitions which are in the range and outside either side of the range, let's say. Now, for this case, we're testing the structure, and it's specified in the notes. What this is actually doing is we're trying to test something that is valid and in the structure, something that is valid and not in the structure, and something that is invalid, so it couldn't be in the structure, and just ensure that we're handling those correctly. So in this case, the first answer, which is the correct one, 52 is it's valid because it's in the range acceptable within our array. But 2, it's also part of this array structure, and then that covers that partition. The next partition, let's say, is outside of the it's like an illegal value, so it's outside of our parameters. So 51 shouldn't be included within the range of greater than 51 and less than 61. So this is outside. So this is another one of our partitions. And then the final partition is checking for a value which is a valid value. So it's within our range for the parameters for the array, for the number of values, let's say, but it's not in the actual array itself, and that would be the value 58. So there's the 3 partitions for this type of structure, and this is more just to remember this from the notes, I guess, that we're looking for these 3 partitions when you're dealing with array structures, when you're doing equivalence partitioning, or when you're defining the partitions. So we want tests that test each of the partitions: 1 valid and in the array, 1 valid and not in the array, and 1 invalid. And so the first option has this, the other 2 do not. They only have 2 of those partitions tested. So the B, for example, it gives 56, which is, valid, but not in the array. And it has 60, which is the same partition, however, because it's valid, but it's also not in the array. So that's actually the same partition being tested there. So that doesn't cover all our partitions here. And then the 57 is valid and in the array. So that's a different test, but we're missing the invalid test. And similarly, but not the same, for C, we have 55, which is valid and in the array, but then we have the invalid test case, which is 51. And we also have the invalid test case, which is 10. So we've got 2 tests for, again, the same partition, and we're missing the test case for a valid test, which is not in the array. So hopefully that explanation makes a little bit more sense. And of course, this might explain that a little bit more. Let's go to the next question. Hi, Prof. Could I kindly double check again on the answer for the TRAT version of the question about the use case testing? Thanks in advance. No worries, very polite question. The use case testing for the TRAT, let me go to it. Let me go find it. Use case testing for the TRAT. So the use case testing for the TRAT had several options. And so in this case, it was many of the options were wrong, but one of them was correct. So let me just cross-reference this to the notes. So if you look at 6.0, lecture 6.0, slide number 4, there's derived from, so use cases are derived from business processes, pardon me, and where use cases must be readable, correct, specific, clear, complete, stable, up-to-date, well-documented. So these are some of the things that use cases should be. So from the notes, so you can cross-reference lecture 6.0, slide number 4. And in the question, the first option, which is the correct one, states that use cases must be up to date and readable in order to translate to tests. So that's obviously referring to the the readable and up to date from the use case testing black box lecture, so 6.01. And of course, all this is for use cases, for use case testing. Of course, this is important to do the testing of the use cases. So it's not just for use cases, this is for the use case testing. So that's why use cases must be up to date and readable in order to translate into tests. So that was given as the correct answer there. The other options were use cases must only involve one actor, which isn't true. Use cases must involve primary system flows in order to translate to tests. Must only involve, primary system flows, which is obviously not true. We also want to look at secondary system flows, like alternative flows. So the first option, well, not necessarily the first option, but the option I'm looking at here would be the one which talks about them having to be up to date and readable as specified in the notes. So hopefully that makes sense. I think most people, most people are getting this correct, but that one is maybe a little bit more. Is this the same person following up, or that's a different question? Oh, this is the previous one. Okay. What would be the difference? I'm gonna get to everyone's question. Sorry, you don't see the messages I see. What would be the difference between the equivalence partitioning and boundary value analysis? Both are testing the valid and invalid, as I'm slightly confused by the boundary value analysis concept. Yeah, it's a great question. So the fundamental difference is the partitioning is kind of like the initial stage, let's say, and then the boundary value analysis is the next stage. So the partitioning is first deciding where the partitions are. So if we have a basic input range of input numbers into a function, we'll have the valid range of those numbers, let's say, and we might have the invalid that's less than this range and the invalid which is greater than this range. And depending on the specification of the function, those two invalids might be one partition actually, but we might consider them as separate as well. So let's say we have one invalid partition of less than the range, a valid partition of the range, and one partition that's greater than the range. And if we're just creating test cases to assess the equivalence partitions, then we're actually just testing any particular value within that range, or invalid range 1 or invalid range 2. So it's kind of like a minimal set of test cases here. Now, when we move to the boundary value analysis, it's actually just the concept of assessing that boundary itself, which is the difference. So in which case, we're now trying to not only test those partitions, but test the boundary values of those partitions of where they're still valid or invalid. And that's why in the kind of range question we looked at, we had one which was like the value inclusive of 1 and 100, right? So we could have we would still be testing this valid partition, but now we have two tests for it because we're testing the minimum of that range and the maximum of that range, and we're testing the invalid partitions on either side, but we're testing, one over that side, so where it meets the boundary of the valid, and one over the other side where it meets the boundary of the valid invalid on the greater end. So the boundary value analysis is really still testing the partitions, but now making sure that they test the actual boundaries where the values would cross over from valid to invalid. So that's the general concept. Now, when you're dealing with specific data structures, the specification gets a little bit different. So it's a little bit different when we're dealing with a range of inputs to a question as to whether we're testing an array, an unsorted array. They actually, in the notes, you'll find that there's like, 5 or 6 test cases, arguably, 5 if you do some overlap for an unsorted array, right, where you actually have to have valid, invalid, etc. But now you're trying to test the actual boundaries, which are for an unsorted array, are actually the first element and the last element in the array. So these are considered the boundaries when you're testing this kind of structure, this storage structure. So that's where it gets a little bit different. Now, in most cases, those type of specific tests for kind of structures and otherwise, we're not necessarily dealing with them so much. We'd be dealing with more inputs, to functions, and we'd have those kind of boundaries in terms of what are the valid and invalid inputs. Those would be our partitions. And then we look at the boundaries there. So that's just a little bit more explanation. Hopefully, the general concept is the partitions are all the valid and invalid partitions for inputs, into our functions, and then the boundaries is really still testing those partitions, but having specific tests for those boundary values. So let me just go back up. Yeah, so to summarize, you need a partition that will run normally and a partition for each type of error in case 1 normal, 1 out of range, 3 not found. This is on this actual slide that we're still looking at, right? Yeah, so you want basically to assess for partition for valid inputs that are in the array, valid inputs that are not in the array, and invalid inputs. Yes, those would be your equivalence partitions for this structure. Yeah. Hi, Prof. Can you go through the IRAT answers for the state transition on with the switch statements on which state transition on which statements are true? Yes. Now, I don't think I put that in the slides, did I? But that's one of the questions. Is that correct? Yeah, well, I'm going to assume that's correct. Okay, so state transition testing is a form of black box testing that involves representing systems as state transition diagrams, etc. Which of the following are true statements about state transition diagrams? Select the correct options. This is the question you're referring to, right? So in this one, all the options were correct. So this relates to, let me find the slide as well. Let's go to the slides. So this is, of course, 6.3. And this relates to from slide 10 onwards, but specifically slide 11 kind of explains the terms of state and transition, inputs and events. And of course, in that we're stipulating that events and inputs are essentially the same thing. Like an input into a system can be considered as an event. You know, a user input is also an event where the user interacts with the system. And so these result, you know, in a transition, you know, possibly. So inputs or events cause transitions, etc. And the states are, you know, are unique instantiated set of variables, of specific variables. So anyway, this would be kind of slide 11 in lecture 6.3. Now let's go back to the question. So yeah, so I provided a few options which are used to describe state transition diagrams. So state transitions can be initiated by events. So again, events and inputs are seen as equivalent. So yes, the events initiate or cause a transition, and they have actions associated with them. So yes, in our notes, essentially every event, did I specify this here? Link state, same sides, concentrate. I guess, I mean, obviously there are normally actions associated with every, okay, well, I did specify in this associated with every combination of input and transition. Okay. And the idea of a kind of action or an output is just some sort of consequence of the input or event. So it's kind of a bit of a soft explanation of it. But of course, when you have a change in state, you know, when you transition from one state to another, there is some sort of output or action which takes place given an input or event. So I was just checking that I specified that in the slides, and it does say associated with every combination of input and transition. And in the thing I said, transitions can be initiated by events and can have actions associated with them. So also, obviously, they can have actions associated with them. And transitions are the way to move from one state to another. Yep. And transitions can be initiated by inputs and have outputs associated with them. Yeah. So really, I'm using the interchangeable terms of input and event and the interchangeable terms of output and action for those options, other than the second option, which is just talking about transitions are the way to move from one state to another. And in fact, in state transition diagrams, they are the only way to move from one state to another. So yeah, I know it's a bit awkward to go through it like me reading it out like this, but yes, it's really based on different phrasings from that slide there. So hopefully that's helpful. Okay, which question is this? Hi, Prof. Sorry to interrupt. You're not interrupting. I'm just because I can't read everything fast enough. Hi, Prof. Sorry to interrupt. For the TRAT question 2, the correct option given only mentioned that it should be updated and readable. However, it could still be incorrect, or will none of the above are correct be accepted? Is the use case question. Okay, let me go back. Interesting. And this is the TRAT. Well, I thought this was everyone scored so well, but there's so many questions. It's great. I'm enjoying it. It's fine. TRAT question 2. Okay, it might be your question. It's not this one here. Like it's the this is the okay. Let me just this is the black box testing, right? Where we drive use cases. Which of the following statements are true of use cases? This is the one, right? Okay. So this is the one I went through. Okay, so use cases must be up to date and readable in order to translate to tests. Well, I mean, this, I guess, so this is another case of kind of the logic of the statements. And generally, I'm not trying to trick people with logic, to be honest. You know, and like when I was added the word necessarily, I mean, I wasn't trying to, I mean, I don't think I even meant to add that word in. But in this case, I think this is a maybe clearer example of this statement still being correct. So in the notes, we obviously had a series of statements, right? You know, and as you point out for question 2, the correct option only mentions it should be updated and readable. However, it could still be incorrect, right? It could be. But in order to be correct, it does need to be up to date and readable, right? So if it is also incorrect, that's obviously would mean it's incorrect. But to be correct, it still needs to be up to date and readable, right? And it's just, you know, it's kind of the same as like, I mean, this is a kind of stupid example, but like to score a goal in like football, you need to, you know, you need to kick the ball. It needs to like, you know, travel towards the goal, and then the goalie needs to, you know, not save it, right? So it's still true to say that the goalie, you know, goalie shouldn't is, you know, the goalie has to not save it, right? Because if the goalie saves it under whatever circumstance, that means it's not a goal. So the goalie still has to not save it for it to be a goal, but you could also miss as well, and the goalie still doesn't save it, but it's not a goal. But it's still true to say the goalie has to not save it in order for it to be a goal, right? So it's like by removing the, you know, the all the terms necessary for a use case to be true, it's still true for any one of those. For any one of those, it's true to say that that needs to be true still, you know, is, you know, but we're not saying that the others may be false. We're not making any assertions there. We're just saying it needs to be updated and readable, you know, and that's still a true statement, right? Even though you don't specify all the other things that have to be true. But yeah, I mean, like, honestly, yeah, look, that one's a bit difficult, because that would mean for every single like context where I'm saying a true statement, I have to mention every single thing that has to be correct. And I guess in this one, yeah, I was trying to keep all of them a little bit briefer. But yeah, I think in this one, that statement is more clearly true. I think the other one that was raised earlier is actually a bit more nuanced, because like necessarily true, it does include obviously it not being helpful, you know, it not helping the development process, right? But it also adds a kind of air of uncertainty, maybe opening up to the possibility of, you know, it could be, you know, beneficial in some way where it's actually not beneficial. And that's where there's kind of gray area there. Yeah, but these are great questions. I mean, some of them are getting like, you know, into the details, you know, I would say pedantic, but I'm quite a pedantic guy about a lot of these things. So I really appreciate that. Let me go a bit further. Oh, is that everything? No, decision tables about the description question, about the order of the rules, I think is not went through. Oh yeah, that's another question I threw in there. Yeah, I tried to be a bit more variable in terms of differences in questions. I mean, obviously it's still the same stuff on decision tables. Yeah, that's from the IRAT. Am I correct? Is that the IRAT? Yes, all right, okay. So let me just read through that one. So decision table testing is a form of black box testing in which the logic of a system is mapped into decision tables, et cetera, et cetera. So you have to choose the correct of the following options. Now, let me also cross-reference the notes here. So this does come down to some of the definitions of the decision tables, right? So let's see which slide specifically talks about it. Yeah, so it's slide number 7 on 6.3, and this talks about, you know, what things are true of decision tables or not. So the order decisions are evaluated doesn't affect the resulting action, or the order rules are evaluated doesn't affect the resulting action. Once a rule has been satisfied and an action is taken, no other rules need to be examined. So these are just some of the definitions of decision tables to stop kind of cyclic logic loops in them as well. So anyway, how does that relate to our question? Well, a lot of these are just either definitions of the rules or inaccurate versions of them. So in this question, there were, well, the three, you know, options given, and then all of or none of. So the first one says the order decisions are evaluated affects the resulting action, but the order that the decisions are evaluated does not affect the resulting action. So the first one is wrong. The next one says the order rules are evaluated doesn't affect the resulting action. So the opposite of the first one, and this one is in fact true. And then the next one says if multiple actions, so actually the first two are kind of contradictory of one another, but interestingly, you know, some people wrote all of the above are correct as well. And then the third one says if multiple actions can result from the execution of a single rule, the order in which the actions take place must be considered. But actually, it's still the case that the order in which the actions take place, you know, doesn't matter. So those three, can I just, let me just, is it here? If multiple actions can result from the exception of a single rule, the order in which the action takes place is ignored. Yeah, so that's this precise wording. Obviously, I just, you know, said it in a different way. So each of these are actually just taken from that slide 7 and paraphrased a bit differently, and hoping that you would recognize maybe what is the correct one. So the correct one was the order the rules are evaluated doesn't affect the resulting action. And so that's why we can have just our sequence of yeses and nos, etc. Doesn't matter which order those rules are evaluated in. So if rule 1 we test, it shouldn't be that we have to finish testing rule 1 to be able to test rule 2. We could evaluate rules in any particular order, and it doesn't have an impact on the other evaluation of a rule, right? And so that's because you don't want to have a system where if you evaluate a rule, it somehow changes some of the behavior of the system, so then another rule wouldn't evaluate in the same way. So that's something that you cannot have with decision table testing, because obviously that would force an ordering of the rule evaluation and such. So that's just something that is given there. Yeah. Okay. I think, and then this question, I think, you know, majority got this right. So the majority of the class, and obviously is the most popular answer as well. But yeah, I think this question did trip a few people up as well. But overall, guys, I think the scores are really good. The scores are much better than last week, much better possibly than the previous week. And once I add the 0.33s, it will get even higher still. And also for the person who's in discussions with the necessarily questions, you know, drop me an email about that one. If you make a good case, I will you know, I will make a mark adjustment for everyone actually, for that question. I think there is a reasonable case to make there. I do feel a bit weird about it because, like, it's not like I wasn't intending to like make that confusing. It just so happened that I used that word. But hey ho, I think it, you know, whether it's correct or not is definitely, you know, I think there's a reasonable debate to be had. And so, yeah, you can follow up. No pressure. I mean, I guess it's not really a huge amount of marks, but yeah, just send me a follow up with a decent case, and if I adjust the mark, I will post on the LMS, and everyone will get those marks. Okay, well, that's great. Well, for the final week, we managed to have like a very comprehensive discussion of all, you know, the answers, and definitely pointed out some, you know, possible confusions and oversights and such. But I think overall you guys did very, very well. So just remember, in the final exam, there won't be any danger of like these kind of misinterpretations ruining people's scores, because ultimately in the exam, you'll be able to give your own rationale and reasoning. So you can write like, assuming that blah, 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 and then give your answer accordingly. And that gives, obviously it takes a lot more time to mark these things, but it just means in the exam, you have a much easier way to have different approaches to questions that are still completely valid. In a multiple choice, it's obviously a little bit hard to do that. This is why we discuss the answers afterwards and go through them in kind of detail. And also, to be honest, I'm quite liberal with the way I do the marking for these things as well. But yeah, thank you very much, everyone. I think we're bang on 6 o'clock. So I guess I'll call it there. I will expect some email follow-ups. And then I will wait until I get email follow-ups before I release the marks. But hopefully I'll see some of you on Friday. If not, no worries. That just means you've already done a great job. And then I wish you best of luck for your other assessments this week, the one tomorrow. And I'll maybe see you guys in the future. Okay, so best of luck.